What's often considered striking and unsettling about quantum mechanics is that at the beginning of the 20th century, people start doing all kinds of experiments where, unlike in the Newtonian case, where we're just taking it for granted that, yeah, there are, you look at these little dust motes or something like that, how they're moving around. They themselves presumably consist of billions upon billions of these elementary point particles, which we can't actually see. We're sort of taking it for granted that things are going to work out. In the beginning of the 20th century, people fooling around with cathode ray tubes and stuff like that begin to be able to keep track of the motions of individual elementary particles. And these particles are behaving in ways that are almost inconceivably bizarre, okay? In particular, people manage to convince themselves by doing lots of experiments with these elementary particles that things like electrons, for example, could be in, it's possible for an electron to be located at this point in space, and possible for an electron to be located at that point in space. Those are the familiar Newtonian possibilities, here or here or here or here or here. What these experiments at the beginning of the 20th century suggested to people, and I'm condensing here 30 years or so of wrestling with the results of these experiments in the beginning of the 20th century. There are certain sets of experiments, so-called interference experiments, double slit experiments, if you can read about this, want to read about this in the literature, neutron interferometry experiments, stuff like that. There's a whole family of experiments which slowly persuades people that that apparently there are certain states that electrons can be in. Electrons and neutrons and all elementary particles can be in. Once again, there's a possible state where the electron is at point A. There's a possible state where the electron is at point B. What people became convinced of is that in addition, there are possible states of electrons such that the very question, is it located at point A, or is it located at point B, or is it located at neither of them, fails to make sense, okay? That the question, that there are certain situations in which the question, is the electron in box A or in box B, or in neither of the boxes, is like, is like a question of the form, is the number 5 married, okay? Or what is the weight in grams of Catholicism, okay? Or something like that. Questions that philosophers often refer to as category mistakes, okay? That there can be situations of a material particle, an electron, okay, where asking whether or not it's in box A is somehow like asking what the marital status of the number 5 is, or what the weight in grams of Catholicism is, okay? This strikes people as absolutely bizarre. People felt forced to conclusions like this because if you tried to tell the story of these experiments in a way that used locutions like, well, at this point in the story, the electron, I suppose, must have been here. Or at this point in the story, the electron must have been there. Or even if you just insist that at this point in the story, there must be some place where the electron was, because after all, it got from here in the beginning of the experiment to there at the end of the experiment, it must have gone by some particular route, either through this route or through that route. you try to insist on that. You try to tell yourself a story about how these experiments went, okay, that's consistent with the results you got. You find that every particular claim about which route the electron might have taken somehow collapses into nonsense, becomes inconsistent with certain of the results of these experiments that you actually did.